Hello everybody. Today we're going to talk about evaluating a function. So first thing is I've made you something that's kind of like a foldable. So if you fold this part over first and then you fold this part over second, it's kind of like a foldable. Okay, so basically what is a function? Well, you've actually done this. It just wasn't called a function. You have plugged in x's to get the y's. In other words, you've plugged in the x part of a coordinate into an equation to get your y. So basically what would go in to the function is called the input. And you've probably you have probably seen the sign that I made that's up over one of the whiteboards that has domain and range. And the domain is what goes in. These are the x values. I think we know that by now. And then this goes in to a function, and the y's are the answers we get. And we know that the y's are the ranges, so let's write y. And also these would be known as the outputs. Okay, so something goes in, machine does something with it, and then you have something that comes out. X goes in, Y goes out. Okay, so let's look at an example. Okay, so here we have an equation, y equals 2x plus 1, and this is the way you all saw it in the 8th grade. And now when we get into 9th grade, we actually use function notation because this is a function. It is dependent on what we put in for x, and so this is the function notation. Notice these look just alike, except for instead of y, they wrote f of x. So this description here, this notation, is the same thing as a y. What does it mean? Well, f is just the name of the function, so you can tell it from other functions. It might be called g, might be called h. And then this little x in parentheses is telling you that this equation, this relationship, depends on what you put in for x. So it's called f of x, okay? So notice now, instead of f of x, they've written f of 3. And this is where the x was, and they've put a 3 in there. So basically what they're giving you is the x value, also known as the input, and you're just going to plug it right into the equation. Okay, so what's going in is a 3, and we're going to plug it into this equation. And I do this a special way, so listen carefully because it's going to help you guys. The 3 is going in place of the x, but if you read this out loud, and wherever you get to an x, you just say blank and put a parenthesis, it'll be all set up for you to plug in. So instead of 2x plus 1, this is 2 blank plus 1. And watch how I'm going to write it. 2 blank plus 1. Notice my x is gone, and all I did was put a blank in its spot. The reason why I put a blank here is because I am going to plug 3 in for x, because that's what they're asking me to put as my input. And now I do the math. This is 2 times 3, which is 6, and then add 1, it's 7. So basically what we have here is the ordered pair, 3, 7. It is a solution to this equation. If you could see a graph of this equation, this would be an ordered pair that would be on the line. Okay, so we put in our x's and we get out the y. Okay, all right, so let's try this. We've got tables, graphs, and equations, and we're going to evaluate functions. Okay, so notice we've got a table with x values, and we're using this f of x notation, but it's the same thing as my y values. So when we evaluate f of negative 2, notice this is where that x was. They're saying when x is negative 2, what is y? Well, y is 4. Evaluate f of 4. Well, when x is 4, y is 1. Okay. And I just put a little challenge problem here, f of 6. Well, you may look up here and say, well, Miss Batchy, we can't do that because f of 6 isn't on there. Remember that with functions, they go on beyond this table. We can only put a few values from the table. We can't fit an infinite amount, but these go on. We just need to look at the pattern. Notice this goes up by 2's. The x's go up by 2's in this particular table. So 0, 2, 4, the next one would be a 6. And now let's look at the pattern here. 5, 4, 3, 2, 1. The next would be a 0. So this is another set of ordered pairs on the graph. So f of 6 is 0. These are my inputs. These are my x's. These are my outputs. These are my y's. Okay? All right. Now, notice this. And this is where it gets kind of tricky because we want to think this is my x value. Well, notice where it's located. It's located on the other side of the equal sign. Well, if it's located on the other side of the equal sign, and notice we've still got the x there, this is actually a y value. And notice they say, what is the value of x? So be very careful that you don't just see this and think that any number sitting there is the x. Okay, these are x's, but if it's on the other side of the equal sign, these are actually the y's. So the y is 5, and they're now asking me what is the x. So let's take a look back up here. The y is 5. The x is negative 4. Okie dokie. Looks like here I didn't change this number. I can change it now. Let's do f of x equals 0. Okay, so this is a y value. So we're going to come up here and look at this y value. We find 0. And then ends up the x value is 6. Okay? So question, what does f of 8 equals negative 1 mean? Well, f of 8 equals negative 1 is telling you we have an ordered pair that is a solution to this function, and that ordered pair is 8, negative 1. This would be the ordered pair on the graph of this equation. And you can tell because if you kept with this pattern 0, 2, 4, 6, the next one would be 8, and then 5, 4, 3, 2, 1, 0. The next one would be negative 1. Okay? So this is an ordered pair that could be found in the table. All right? Now this was with tables. Okay, now let's take a look at with graphs. Okay, so let's take a look with graphs. It's going to work the same way because remember, all of these ordered pairs can be plotted on a graph to make a line. So this function is called g of x. Again, don't get upset about the g's and the f's and the h's. All they're there for is to separate the different functions and give them a different name. Okay, so g of 0, remember if it's placed here, this is the x value. And we want the y coordinate of that ordered pair. So you've actually done this before. 0 is where the x is, and if you find your line, it's right here. This is the ordered pair, 0, 2. So a 2 goes there. Input, output. Okay, g of negative 3. Take a second and see if you can find the y coordinate of the ordered pair that has x is negative 3. So just take a second before I tell you how to do it. Okay, x is negative 3, and we find that we're right here on that line, and that is the ordered pair, negative 3, negative 4. So the output is negative 4. Okay, these are the y's or the outputs. All right, notice here, this is changed. This is not your x value. This is your y value, and they want to know what the x value is of the ordered pair that's contained on this line. So now we're looking for a y value of 6, a y value of 6. So if I find my y value of 6 and I go over, the x value is 2. It's the ordered pair, 2, 6. So if y is 6, x is 2. Not very hard. Okay, so I'm going to take a moment and let you see if you can find the ordered pair for g of x equals 4, so y is 4. See if you can look up on the line and find the x. Okay, y is 4 right here, and if I follow it across, this is the ordered pair 1, comma 4. Yeah, be careful, don't do what I just did. 1 is the x value, 4 is the y, so the answer here is 1. Again, this is kind of tricky. This is where students really make their mistakes. You need to know if it's placed here, this is an x value they're giving you, but if it's on the other side of the equal sign, this is the y value. Okay? And just another, what does f of negative 1 equals 0 mean? It means that the ordered pair negative 1, 0 is found on the line. Okay? All right. So we looked at evaluating a table, evaluating a graph. Now the hard one, this is the harder one, evaluating an equation. Okay, so I'm using that same equation that I used back here, and they want us to evaluate this function where x is 3 again. So what does this sound like? And again, it's really going to help you guys out if you do it my way. We know the 3 is going to go there, but listen to how I say it. It's 2 blank plus 1, and we're going to write 2 blank plus 1. Okay, so 2 blank plus 1, and they want me to plug the 3 in. When I do the math here, I get 7. So we've got the ordered pair 3, 7, which satisfies this equation. Okay, f of negative 2. So they're giving us a negative 2 to plug in. Well, what does this sound like? 2 blank plus 1. I'm going to write that. 2 blank plus 1. And I'm going to put negative 2 in place of where that x was. So 2 times negative 2 is negative 4. And then plus 1, negative 4 plus 1 is negative 3. So the ordered pair negative 2 comma negative 3 is a solution to this equation. Okay. Notice things are changing here. This is not an x value. This is a y value. It has to be plugged in where y would be plugged in. So we do not want to plug it in here. If you remember when we discussed this, the y value is on the left-hand side. It's the same thing as f of x. So I'm going to plug in the negative 11 on the other side of the equal sign. So it's going to be 2x plus 1 equals, and on the other side of the equal sign is where I'm going to put the negative 11. Now take a look at this. Hopefully you recognize this. It is a two-step equation. So we're going to subtract 11 on both sides. Bring down my 2x, bring down negative 12. Last step, divide both sides by 2, and we get x equals negative 6. So the ordered pair negative 6, negative 11 also satisfies this equation. Okay. Y equals 15. So that's going to go on the other side. This is not an x value. We do not plug it in for x. We're going to write 2x plus 1 equals 15. And we're going to solve the two-step equation to find the x coordinate for that point. So we're going to subtract 1 on both sides. 15 minus 1 is 14. Last step, we're going to divide by 2. And we get x equals 7. All right, evaluating functions. I'm pretty certain that you have found points on the line before. I'm pretty certain you have plugged in x values back in the 8th grade. You've just never seen the function notation, and that's what you've got to get used to. Okay? All right. Y'all have a good one.